Only 80 years ago, we could come no closer to Mars than straining to see a tiny, shimmering image through a telescope in Arizona. Now, our instruments have actually touched down on the planet. Viking is a legacy of H.G. Wells and Percival Lowell, Robert Goddard. Science is a collaborative enterprise spanning the generations. When it permits us to see the far side of some new horizon, we remember those who prepared the way, seeing for them also. On each lander, there is a microdot on which is written very small the names of 10,000 men and women responsible for Viking's splendid achievement. One of the names in this microdot belonged to a friend of mine, a remarkable microbiologist named Wolf Vishniak. He was the first person to build a machine to look for microbes on another world. His friends called it the wolf trap. It contained a liquid nutrient to which Martian soil would be added, and any microbes that liked the food would grow in that nutrient medium and cloud it. The wolf trap was selected to go with Viking to Mars, but NASA is especially vulnerable to budget cuts, and the wolf trap was removed as an economy measure. It was a terrible blow to Vishniak. He'd worked 12 years on it. Others might have stalked off the project, but Vishniak was a gentle and dedicated man. He decided instead to study the most Mars-like environment on this planet, the dry valleys of Antarctica, which were long thought to be lifeless. But Vishniak believed that if he could find microbes growing in these arid polar wastes, the chances of life on Mars would improve. So in November 1973, Vishniak was left in a remote valley in the Asgard Mountains of Antarctica. He set up hundreds of little sample collectors, simple versions of the Viking microbiology experiments. On December 10th, he left camp to retrieve some samples and never returned. He had wandered to an unexplored area, apparently slipped on the ice, and fell more than 100 meters. Maybe something had caught his eye, a likely habitat for microbes or a patch of green where none should be. The last entry in his notebook was Station 202 retrieved, 22:30 hours. Soil temperature minus 10 degrees. Air temperature minus 16 degrees. It had been a typical summer temperature for Mars. Some of his soil samples were later returned, and Vishniak's colleagues discovered that there really is life in the dry valleys of Antarctica, that life is even more tenacious than we had imagined. That fact may turn out to be very important for the future history of Mars. There will be a time when Mars is thoroughly explored. What then? What should we do with Mars? If there is life on Mars, then I believe we should do nothing to disturb that life. Mars, then, belongs to the Martians, even if they are microbes. But suppose that Mars is in fact lifeless. Might we, in some sense, be able to live there, to somehow make Mars habitable like the Earth, to terraform another world? As lovely a world as Mars is, it poses certain problems for us. There's too little oxygen, no liquid water, and too much ultraviolet light. But all that could be solved if we could make more air. With higher atmospheric pressures, liquid water would become possible. With more oxygen, we might be able to breathe the atmosphere, and ozone could form to shield the surface from the solar ultraviolet light. The evidence for past liquid water suggests that Mars once had a denser atmosphere, which can't have all escaped to space. It has to be on the planet somewhere. In subsurface ice, surely, but most excessively in the present polar caps. To vaporize the ice caps, we must heat them. preferably by covering them with something dark to absorb more sunlight. That thing ought also to be cheap and able to make copies of itself. Well, there are such things. We call them plants. We would need to evolve by artificial selection and genetic engineering dark plants able to survive the severe Martian environment. Such plants could be seeded on the vast expanse of the Martian polar ice caps, taking root, spreading, giving off oxygen, darkening the surface, melting the ice, and releasing the ancient Martian atmosphere from its long captivity. We might even imagine a kind of Martian Johnny Appleseed, robot or human, roaming the frozen polar wastes in an endeavor which benefits only the generations to come. It might take hundreds or thousands of years. We might then want to carry the liberated water from the melting polar ice caps to the warmer equatorial regions. And there's a way to do it. We would build canals. But that's exactly what Percival Lowell believed was in fact happening on Mars in his time. The idea of a canal network built by Martians may turn out to be a kind of premonition. Because if the planet ever is terraformed, it'll be done by human beings whose permanent residence and planetary affiliation is Mars. The Martians will be us.